Morning, everybody. We're going to go ahead and wait just a few more minutes to give additional participants time to join us, so please hold tight. Okay, let's get started. This is Rhonda McElwain talking in the Office of Gift Planning, and I want to thank you all for joining us for our virtual First Fridays webinar. A few housekeeping notes for everyone before we dive in. I know this is a very different format than what we're used to, but you can view this webinar like a virtual lecture hall. Please feel free to use the Q&A and chat functions at the bottom of your screen. Ask any questions you have for Kelly, and we can address those throughout the program or at the end of the presentation. I'd like to introduce our speaker today. We have Dr. Kelly Lambert, who is the Trawick Professor of Behavioral Neuroscience and Psychology and the coordinator of the neuroscience program here at the University of Richmond. Kelly received her PhD in biopsychology from the University of Georgia and enjoys teaching courses related to neuroscience, behavioral processes, and evidence-based methodologies. Dr. Lambert's research focuses on experience-based neuroplasticity and using rodent, raccoon, and non-human primate models. She has received multiple teaching awards, including the Virginia Professor of the Year and the State Council of Higher Education Outstanding Professor Award. Additionally, she is the recipient of the 2018 Outstanding Achievement Award given by the International Behavioral Neuroscience Society for her research accomplishments. Dr. Lambert has been interviewed on several radio shows and podcasts, and recently her research targeting connections between physical effort and emotional resilience was featured on CBS Sunday Morning. And her rat driving research was featured in over 1,500 news articles across the world. In 2019, Dr. Lambert described her behavioraceuticals research in a TEDx talk in Bermuda. On a personal level, Dr. Lambert is married to Dr. Gary Lambert, an industrial organizational psychologist. They have two daughters. Laura is a graduate of Elon University and works in corporate communications at West Rock in Atlanta. And Skylar, a recent graduate of Furman University, will begin medical school at the University of South Carolina at Greenville in July 2020. Without further ado, Dr. Lambert.
Thank you, Rhonda, with all that psychobabble about brains and behavior. But it's a real treat to be here with all of you, and so wish that we were in a venue where I could see all of your faces and we could have some coffee and maybe a croissant or something. But this is what we have. This is our new reality. But I'm glad that you took time out on a beautiful Friday morning here to spend some time with us at the University of Richmond. And we have transitioned back to the lab, just my small team, no students. So I'm in my office, so I'm at the University of Richmond, so it feels good to be here. So what I wanted to do today is talk about how professors who are in the business of teaching, that's students and teaching, that's my #1 love, but how we also conduct research, and more specifically in my case, the behavioral neuroscience research. It is very different from some of my colleagues at larger universities. I wanted to talk about that experience with you, and research suggests that if you go to the dentist and you know how painful it's going to be, the pain is a little bit easier to withstand. So I want to tell you what's in store for you. Look at our journey so you kind of know where we're going. So maybe it won't be too painful sitting through all this. But I want to tell you about some of our projects, trying not to get into too many of the nerdy neuroscience details, but to give you a snapshot of what we're doing in the lab here at the University of Richmond with our undergraduate students. Well, first I'll tell you a little bit about what the field is, and then do that, and then tell you a little bit about the students and how they can be involved, and how a little bit about the wonderful work they're doing, and then mention some of the logistics of the challenges of doing research at a smaller university or college. And I spent a good bit of my career at a smaller college, Randolph-Macon College. So I've always worked with undergraduate students. That's my love, my passion. They're incredibly smart. They keep me on my toes. So we'll talk about the logistics of trying to do that with undergraduate students. So I'll try to talk about, I'll keep myself maybe 25 to 30 minutes, and that should give plenty of time for your questions, your comments, thoughts. So please feel free to start type those in when you have them. We will wait till the end, and then I think Rhonda is going to shoot them back to me, and hopefully we can have a nice conversation, and hopefully you've got your coffee, can stay awake through this. But a little bit about what behavioral neuroscience is, and that's what this field is. There's really three things that we're looking at: the interactions with or among behavior, and I have a rat here to depict that. We work with what we call preclinical models. So that's the animal models before you would test something with humans if we're looking at something therapeutic. So the rats, they outsmart me all the time. We are very respectful of these animals, and we also, so it's behavior, the brain, how behavior influences the brain. This is a picture of a rat brain, very tiny, about 2 grams brain, but even with that tiny brain, they're outsmarting a lot of humans. And then there's environment. And it's not enough to just know how a brain operates within our heads. We also need to think about the context. I'm always telling my students, context matters. So your brain's going to operate differently in the midst of a pandemic or a vacation or a university, or in very different situations. So I'll mention a little bit about how we look at different environments and our animals, and of course we're thinking about that with humans as well. So behavior, brain, and environment, that's what we're interested in. More specifically, as Rhonda said, we're interested in this term neuroplasticity, or experience-based neuroplasticity. How our experiences change our brains, and that's all neuroplasticity is. It's our brain's ability to change throughout our lives. From the womb to the tomb, our brains are changing, and this is, I think, I'm very optimistic about this. It's very hopeful that we can continue to change our brains. If we do bad things or things that aren't good for them, they can change in a negative context. But through enrichment and engagement, our brains can change. And this is a picture of a rat brain, and I'm so nerdy that I think brains are just beautiful. So we stained this, and these are what we call neurons, the brain cells. And so we can look under high magnification and look at all the characteristics, the number of little branchy points they have, and how big their cell bodies are, and how they're aligned. This is in an area called the hippocampus, named after a seahorse, because when you look at it, the whole thing kind of looks like that. And I think the hippocampus, in many areas of the brain, they just look like beautiful gardens, the way the neurons are planted and structured, and we can learn a lot through neuroanatomy, and there are some other ways that we look at the brain. But I've always told my students, one day we're going to do an art show with just pretty pictures of the brain. But experience-based neuroplasticity, now that we know that brains can change, I share with my students that it makes us very accountable for what we're doing with our brains. So the students are in the perfect place for, I can't think of a more ideal environment for changing brains on a university campus. And I know you guys have probably experienced that, but we're all experiencing changes in the context of our lives. And I hope all of you are hanging in there. I know we're not at our best now, but that we're all hanging in there, and you probably feel that this is changing our brains. And so we're all accountable for, what is happening or how we're treating our brains in the context we put it in. Sometimes we don't have control over that, but we need to when we do have some sense of control, we need to use that because our brains are changing. So I love mysteries, and we're in the field of behavioral neuroscience. A lot of us are trying to look at mechanisms that will translate to humans, and the National Institutes of Health, their big word, buzzword, and it's a great word, is translational research. How can what we're studying about our rat translate to humans? And I get that a lot. Not many people work with rats for a living, so I have to defend this. Their brains have really all the same brain areas we have, all the same neurochemicals. Those neurons I just showed you look exactly like ours. Our brains are much bigger and more complex, but it's a nice starting point to learn about ourselves. And we have a lot of control in the laboratory. So we're always cautious about what we've learned from the rats. But it's a good starting point in addition to other things. But one mystery that we've been very interested in is why the rates of depression are continuing to rise, even though we're at a time where we have all this advanced medicine and different drugs, antidepressants, a multi-billion-dollar industry. The depression rates are rising, and we are not seeing a decline in the very unfortunate death by suicide, which is many times an endpoint to these depression rates. So why is that? Why at a time where we seem to have, all of this technology, life seems to be good, and we have this medical knowledge and these tools, these pharmacological tools, what is happening? What are we doing wrong? So several years ago, when I was on a sabbatical, actually, I just went to the drawing board. My drawing board is the brain. And so going back to look at the brain, I was struck by how much of the brain's real estate is devoted to movement. So this that I just highlighted is the cerebellum. Over 70% of all of our brain cells are in this structure hanging off the back of our heads, our brains. And it's involved in motor coordination and movement and some other things, but that's what it's most noted for. And then this huge area in the center of our brain called the basal ganglia, striatum, involved in coordinating movement. And then this big strip on the top of our head, the motor cortex, controls our muscles. So this is a good bit of our brain's real estate. We've evolved where movement is important. And I was struck by this little area here called the nucleus accumbens. And see, I said I wasn't going to get all into the details, and now I am. But that's our brain's, simply speaking, reward center. Or it tells us what's important in life. And it has lots of connections with this middle area involved in movement. So I started to think, why, if depression rates are changing, is there something about our lifestyle that has changed over the last maybe 100 years, last century, where these rates are increasing? One thing that stands out in our lifestyle over the past century is our physical effort. The amount of physical effort we expend to have a meal, to build a home, to make our clothes. If you think of, I always think of Little House on the Prairie. We think of our ancestors and what they had to do. And then if something broke, you had to physically fix it. The old Sears and Roebuck catalog, it told you how to repair your sewing machine when you bought it or something. We don't do all that. We just push buttons and we order things. So this is a different way to think about something like depression, but I started to wonder if as we have reduced the amount of movement and physical effort in our lifestyle, what impact does that have on our brain? And are things more rewarding when we actually have a little effort, a little skin in the game? It's been very interesting to me how during the pandemic, and I don't know if it's a form of coping, but it seems to be kind of a form of coping. I keep hearing about people making bread and doing these things that may be kind of in some way medicinal for our brains. So I wanted to take this idea to the lab, to the rats. And I developed something called effort-based reward training. So not just reward training, but effort-based reward training. So we train our little rats to work for rewards. Now, they don't work for money. I haven't found a rat that works for money, but they work for Fruit Loops. So that's our currency in the lab. So we just have a big arena, and we have little mounds of bedding, and we start with a Fruit Loop on top, and then we gradually decrease it. So they have to, it's minimal effort, 5 minutes a day. They have to actually dig down there to get the Fruit Loop, and then they look for another mound. Therefore, we train them. It's pretty, a lot of rat training isn't too intense, but we do this for about 6 weeks. So I tell the students they are the rat coaches, life coaches. And then we compare these to animals that are given the same number of Fruit Loop pieces, and they are placed in the same arena. So very similar experience, but they don't have to work for it. They are just given the Fruit Loops. So these guys are yoked, and of course we have several animals. And by yoked, I mean that if this rat ate one Fruit Loop piece, this rat would be given one Fruit Loop piece. But we always give it to them in the same little place, and they don't have to work at all. So we call this contingent training. Their reward is contingent on digging in the task, and this is non-contingent. They get the reward no matter what they do. So my students and I enjoy calling the non-contingent rats the trust fund rats. They just get it no matter what. And then the contingent rats are worker rats. They only get the reward if they put the work in. We actually have an NIMH grant, a National Institute of Mental Health grant, to look at this. The title of that grant is Deconstructing Depressogenic Susceptibility and Emotional Resilience. We're trying to, which is a gobbledygook for, I'm interested in the emotional resilience in these animals, and if they may be protected against the emergence of something like depression, a mood disorder, or stress, or anxiety. And we've been doing research, for about 15 years I have with this model, and we find that our worker rats have healthier stress hormone profiles. They have more of that neuroplasticity I was talking about. They seemed, and this is what I love, when I give them a problem that they don't know the answer to, they stick with it longer. I call it learned persistence. There's a term in the field known as learned depression, where you maybe learn that it doesn't matter what you do, you're not going to change your circumstances. But learned persistence is the more optimistic, kind of the flip side of that. And so the trust fund rats will start with a problem, but then they give up a little bit sooner. So the worker rats, maybe they've had more experience with failure. Failures are superpower because we have to learn from the failures, so it gives us more opportunities. So as we transition or translate this back to humans, I wrote an article several years ago for Scientific American Mind about this, and they entitled it Depressingly Easy. And that's an interesting way to think about sometimes our lifestyle. We work hard, even if we're sitting in a chair like I am now or typing, but the nature of our work has really changed for humans compared to even my grandparents who I usually tell the story that in the 1930s, there was at the World's Fair, they introduced the television for the first time. And in the New York Times, they wrote an article and they said, this thing was introduced at the World's Fair. It's kind of neat, but they didn't say, I'm paraphrasing, obviously, but they said, this probably will not catch on because who has time to sit in front of a TV at night? And they showed a picture of a family all sitting in front of that screen because there were other things to do. And I remember my grandmother sitting on the front porch in Talladega, Alabama, shelling her peas or shucking corn, always doing something if you're sitting down. So using your hands in those constructive ways, what the rats are telling us is it gives us a heightened sense of control over the world. So maybe if I don't have control at work, when you go home and clean the house or plant a garden or do woodwork, it reminds the brain, like in little vitamins. I call it kind of mental health vitamins, these effort-based rewards that we do have some control over the world. So maybe our advanced, sterile, Western society may not be perfect for the brain. So introducing little bouts of these effort-based rewards might be helpful. So I do fear that as humans have traded in useful tools such as spears for selfie sticks, that we may be losing some aspect of our brains. So as Rhonda said, I made up this term behaviorceuticals to kind of rival the idea of pharmaceuticals. That's our go-to way to treat a lot of mental illness, and it certainly has its benefits, but we haven't had these breakthroughs where we're really helping people so that we're decreasing the rates of depression. But behaviorceuticals just refers to the idea that through behavior, we can change neurochemicals, like that reward neurochemical dopamine, or what we hear about with depression, serotonin. We can alter all of these through behavior as well. So this is one article I wrote. The artist did like a medicine cabinet, but they're little crafty things instead of drugs there. So nature's idea of prosperous brains, where we're very active and engaged and always doing things, and with our ancestors, it was with our hands, may not be in line with our current or contemporary idea of prosperity, where we work really hard to pay other people to do everything that our ancestors did. So kind of flipping that around, it's interesting to think about that. We're also interested in, as I said, context and environment. We've known for decades that if you put rats in like a Disney World environment instead of a sterile cage, their brains are more complex. This was started in the 1960s at UC Berkeley. And so for about as long as I've been teaching, which is over 30 years now being a professor, we've been looking at types of enriched environments. And our little tweak of that paradigm is that we look at animals not only in kind of a lot of the research, almost all the research uses these artificial kind of plasticky toys and things in the environment, and you change these, and that's great. But we were wondering, what if you had natural stimuli or objects, and we control instead of a plastic ball, some type of wooden or a ball made out of vines, or instead of kind of manufactured bedding, even though it's corn cob and kind of natural, we have kind of dirt and peat moss and stuff like that. And so we have found generally that the rats are kind of equally smart. I call them the city rats and the country rats. But for emotional resilience, and this may be related to depression, our country rats are a little bolder. So if we expose them to something like swimming that they've never done, and it makes their stress hormones go up, they're more likely to dive, which just blows my mind. They're like rat scuba divers. They've never been in water, but they think, oh, let me just go down and explore. So they're more exploratory, and their stress hormones are lower. So for kind of our mental health, I think being exposed to these natural elements in some form is healthy. But being engaged in new environments with new objects and being able to interact with them, regardless of whether or not they're city, country, artificial, or natural, is good for the brain. On a kind of practical note, because our animals are in the laboratory, and almost every laboratory on the planet, they house animals in cages that look like this, not this tube. I'm going to get to that. And this is a very small environment. It's very efficient, economical, but very boring and not enriching for the brain. And it's not probably going to be possible that all of these huge labs are going to have these fancy, messy, enriched environments, because you lose a sense of control. So for the last several years, my students and I have tried to come up with a compromise that maybe we could add to the standard laboratory, university laboratories, that would give the animals some form of enrichment. And when we hit the literature, we think that being able to travel is very enhancing for the brain. And so we did a template and constructed we call them the UR Rat Lofts, where they can travel from upstairs to downstairs through this tube. And you see them going like they're on a little subway or something like that. So we're in the midst of learning and comparing these to the standard housed animals. So as we have been with our stay-at-home orders, we're kind of feeling this wander, the wanderlust, where it would be great to get out and explore new environments. So we're looking at this as a compromise for different labs. So just a few other things before we talk about the logistics of the lab. We're also interested in parenting and how that changes the brain. And rats are wonderful moms. I had to go take a class at a hospital about how to be a mom. These guys have 14 pups, and they know exactly what to do. So as I was pregnant years ago, I stood in awe of these animals that knew exactly what to do. But that's when life is good, when they have all the resources they need, at least in the lab. More recently, we've been interested in what if kind of a model of low socioeconomic status. What if we take some of the bedding away so it's not as cushy here? They don't have as much nesting material. And this creates something called early life stress. Maybe similar to, we hear a lot about ACE and with human medical, in the human medical world, adverse childhood experiences, and how early life stress and trauma can have a long-term impact on cardiovascular disease and diabetes and cancer and a lot of different mental illness. So we have been amazed at when we look at, when we restrict the resources, it alters the mother's attention toward the pup. She's not quite, she seems more confused. And then now we're following the pups to look at their development when they were raised by a mom that was distracted with low resources. We found a lot of interesting behavior things and brain things. We're still looking at the brains of many, but their morphology, their shape of them is changing quite by accidents, a serendipitous discovery. We noticed that animals with early life stress and these low kind of resource conditions have shorter tails. And so we're collaborating with the bioengineer at VCU now who's doing bone scans of the foot and the tail. We're looking at tendons and cartilages. These are some of the biggest differences, the biggest effects I've ever seen in the lab. Having all the food and everything, temperature, there's no predators, but little less resources is changing their growth rate. This is nothing compared to human moms and the stress many face, especially in low economic status situations. So we think that there's a lot that we can learn that would translate and really sound the alarms about how important it is to try to mitigate this early life stress in human moms. I'm a big critic of my own work. We need to be. It's not great to only look at rats, even though that's what my industry is kind of geared up to do. We also need to look at some other brains. So I don't have raccoons in the lab, but I'm working with ecologists, wildlife biologists, and such, so that when some are used in even the USDA as they're looking at rabies research, I'm sneaking in and trying to get their brains and trying to do some behavioral research. I love raccoons. One, their brain is amazing. It's like a small primate brain, and it is profiling like a primate brain. I know they're not primates, but you see all these little wrinkles. That means they have more surface area, unlike that rat brain is also larger. And they've got these forepaws, hands like our hands. These are our best tool, and they're using them in most often driving people crazy. But for all the reasons they drive people crazy, their curiosity, how mischievous they are, that's why I love them. So we're looking at raccoon brains. One of just a handful of people, I think, on the planet looking at raccoon brains. There's not even an atlas really for it that someone has already generated. So we're looking at these guys in the best ways we can because we need to generalize to other species. So I'm looking at things like effort-based rewards, their learning ability, their ability to go into new environments and solve problems, and we hope that will translate to humans. And my past institution, and I still have ties to this, ties to DuMond Conservancy in Miami, where we're doing just observational work, what we call non-invasive work with different primates. I don't know if you visited Monkey Jungle or the DuMond Conservancy in South Dade and Miami, but I've been associated with this place for 30 years and just love it. These are students. I used to take animal behavior class, and students in my animal behavior class there, and I'm hoping to gear this back up now that I'm at the University of Richmond. I actually had a little trailer to do field research there. But look at these faces. I mean, I love a good lecture. I love to talk to students and to teach them in the classroom, but I rarely get the open mouth, awe kind of look. This is what being in the field and nature does for students. I've been struggling with distance learning, online learning, because I like the real person context. I mean, even the classroom's a bit artificial. When we can get students in the field and they're watching about 100 of these guys jump beautifully through the trees, and they would eventually, they're kind of tourists then, but they eventually become researchers in this context. And we're working more with other species there, such as crab-eater monkeys, the macaque monkeys, but they have several different species. They allow our students to go into the field with them after they're properly trained, and we can get their poop. That's why we look at stress hormones, to get their poop. So they don't mind giving us that, and that gives us a little biomarker, a window about what's going on. Even looking at microbiome, we hear a lot about probiotics and how that affects all of the microbes that we're carrying around. So we can still learn a lot in the field, even though we're not in the lab. So I think it's real important to look at different species and to look at different contexts in the field and the lab as we're trying to understand what the kind of universal truths are about behavior across mammalian species. So you got up early on a Friday morning. I wanted to throw in the rats, the driving rats. Rhonda mentioned that I've never gotten more media attention over anything, even our more serious work. This turned out, this is what's wonderful about being at a liberal arts institution. When I came here, Beth Crawford, who's a cognitive psychologist, came to me and said, Kelly, she knew I worked with rats, and she's into cognitive science, could you teach a rat to drive a car? She had seen a museum exhibit where goldfish were kind of maneuvering an aquarium. They weren't consciously aware of that, to our knowledge, but it got her thinking about animals driving things. Of course, I thought she was joking and typed that ha ha ha, and then I thought, oh, maybe I need to be a team player. So before I knew it, we were sitting down. In talking about this, I was designing a car that she would build, thinking about training, and we did several types of studies, but then her group actually built a car that they could steer. So this is it's not just press a bar to get a piece of Fruit Loop. We're going to put you somewhere in this, and you're going to, even though rats don't have good vision, they're nocturnal, they're active at night, regardless of where we put them, they would figure out how to get, and this is a Fruit Loop tree, to get to the Fruit Loop, and then there'd be a little place there, it's kind of like a drive-through, where they could actually get the Fruit Loop. This took a lot of training, and it just reminded us what that tiny little rat brain, remember that picture, can do. It can steer a car. We also looked at animals that were in enriched environments versus standard environments to see if they could learn this complex task. So we're combining nature and technology here. And the ones in the enriched environment, they learned it in about 22 trials. This was driving forward. It wasn't as complicated as the steering. But the standard house rats never really learned it. So I was joking that the enriched animals got their rodent driver's license, but the standard ones didn't. So the environment, the context that we put our brains in, they'll help us with all this technology that we're having to use right now when we're kind of in the midst of this pandemic. So environment sculpts, and our behavior sculpts our brains, and this is important to know. So the students, that's what we're all about. This was last summer. This is typically what my world is like at this time of the year, and it just breaks my heart that this is not, we've got kind of a skeleton crew, but no students. I've hired a recently graduated student who's going to be able to work some. I have a few students working remotely, but it's hard to do what we do remotely. They've got our lab t-shirt on here, so we usually, Dr. Kent was a postdoc, and she just started at VMI with her own lab, had a high school student, and then our undergraduate students. And we just work really hard in the summer to produce the data, and then they analyze it through the year. We call our lab the Ratical Lab. Haha, it's kind of nerdy. Our undergraduate students, they have been my collaborators for over 3 decades in the lab. They're young brains that are much younger than mine. They learn these techniques, their skills are wonderful, and it's so great to see them put that white coat on and become professionals in the lab. And it's also great to see them, after they've done that hard work, present their work at conferences, and they're just, you can just see how they're beaming with pride here as they present their work at various conferences. Jack and Nick presented at the Society for Neuroscience in where was it? Chicago, I think, last year. These two, Nate was our first rat car driver trainer, and Dmitry, who's from Russia, they presented at an international conference. And Ali presented last year at the International Behavioral Neuroscience Society in Australia. I was able to take her there. Bilal is the recent graduate who's going to be working with me some this summer. He's from Lebanon. And so we've just, the students they just never cease to amaze me. And they keep the ideas coming for me. And it's really wonderful that I get to work with these young brains, these bright students, for my entire career. So I really love this. And a lot of these students, Dmitry and Nick, Dmitry starting at the University of Illinois, and Nick at the University of Virginia in PhD neuroscience programs next year. Several are in intermediate programs, post-bac programs for medical school or in medical school. So many are on a track for graduate school or medical or paramedical types of degrees. So when do we do research? Because I'm doing a lot of teaching, and professors have committee work, and so we do have seasons of research. As I mentioned, the summertime is our kind of go-to time where the students are here full-time. They're working 40 hours a week, so we do most of our research in the summer. But then we have students who are doing independent studies through the academic year. So I usually have about 10 students who are working with me through the academic year, and they may be working with brain slides or doing different tasks, working on projects. And all of these students become co-authors with me on publications. So they are my professional collaborators. Funding is a logistical issue when you're at a place like a small liberal arts institution. The University of Richmond it's wonderful. I've been the chair of the undergraduate research committee for the past 2 years, and we get to give money to students to do research, and that's great for the summer. So that provides some resources for students to stay on campus in the summer. It doesn't cover the supply. They get a little bit of supplies, but it's so expensive to do this type of research. So I'm very fortunate to have an NIH grant, as I mentioned. We have to work really hard, and I have to spend a lot of my time writing proposals. We're currently writing for the Raccoon Project to the National Science Foundation. So it takes a good bit of my time to write these proposals to try to get funds that will support the student research and allow them to go to conferences and such, in addition to how generous the University of Richmond has been. So that's something that's always on my mind. Also, being at a smaller place, one of my lifelines, in addition to the students, are my grown-up collaborators at different institutions. And sometimes I refer to myself as the Forrest Gump of neuroscience. I have these wonderful people that I've just bumped into, and they say yes to work with us. And so individuals at Vanderbilt, UMass Boston, Sarah is trapping raccoons in Wyoming, and we get to go out there. Renee is a bioengineer. Amelia is working with these, Amelia and Lorenz are collaborators on the grant, so that not only is this good for my brain, these collaborators, because they have wonderful techniques they can share, but the students get to go to their labs sometimes. And this summer we're planning Zoom lab meetings so that some of these individuals can come into the lab, Zoom lab, and tell us about their techniques, since we can't be on campus learning about them. So it's really fun to be able to benefit from all of the smart brains that these collaborators have. And this is just a sampling. We have several more we're interested in. As we're talking about research with the students, and especially the use of animals, and I'm a huge animal lover, and we're very respectful of how valuable you know, all animal life is, and how we need to make the most of the research we do. The topic of meaningfulness and translation of research comes to mind. And I threw this together because just like over the past month, I've learned of 3 books, recent books, some are just now coming out, that have stories of what my students and I have done in the lab. So this one, this is in the mail to me. I haven't read. As we're talking about effort-based rewards and such with the rats and connections with food while we drive. So I don't know if you know Matt Crawford. It says my connection is unstable. Hopefully I've been coming through. Matt Crawford is the husband of Beth Crawford, who talked me into teaching rats to drive cars. He's also author of Shop Class as Soulcraft, which is one of my favorite books about the importance of the blue collar work in a white collar kind of industry. And I really respect that with effort-based rewards. So this is coming out today. This book is released today, While We Drive Toward a Philosophy of the Open Road. And he writes about the, in fact, and in the beginning, he thanks, in his acknowledgments, he thanks the first 2 rats, Mario and Luigi, who learned to drive. And then the Well-Gardened Mind, about the effort-based rewards and gardening and how that may be restorative to the brain. So that makes us feel good that our research is getting out to the public and is disseminated in that way. As usual, I've talked too much, but I wanted to give you kind of a snapshot of what we're doing in the lab, original research. We don't want to just do cookbook kind of stuff where we already know the answers. We want to contribute to the discussion of mental health and resilience and just how our brain works. And the students are helping, they're doing that. And I'm just trying to provide the resources for them to do that. So I'm interested in any thoughts or questions you have. I'm also very interested, since I'm such a huge advocate of undergraduate research, if you've had any interesting research experiences when you're at the University of Richmond, that would be really great to hear as well. So I'll throw it back to Rhonda, and I guess I'll stop the share here.
Yeah, we have a couple questions, Kelly. And the first one is, what do rats and other lab animals tell us about our individual differences, i.e. mental health?
Yeah. Oh, I love the individual differences, because too often we just group animals together and we think they're all the same. And so even though the rats, we order them from the same place and they're almost genetic clones, we are loving looking at these individual differences, especially related to coping. So when I showed you the 3, those rat lofts and the 3 cages that had the tubes, I didn't kind of elaborate, but when we introduced them to those cages, that's all new. They haven't been in a cage with a hole in it and a tunnel. And the rats act differently. So in one cage, they took all their bedding and the top and filled up the tube. I mean, because in nature, a hole, that could be something a snake could come through. So they just filled it up. And then the second cage, they filled it halfway up, but then said, you know, maybe it's okay. And the third cage, they didn't put any bedding in. They just started going, you know, up and down. So coping and how we deal with stress, we're always looking at that with the rats. So as we look at responses and stress hormones, excuse me, and those the neuroplasticity of the brain, we're starting to try to map. So I've been talking too much. Excuse me. Map these individual differences on to what's going on into the brain, and then kind of related to mental health. It could tell us more about risk factors, or what we can do if we have risk factors to try to treat ourselves in a precautionary way before a mental illness comes on board. And that this is one huge difference between mental illness and some other non-mental illnesses. Cardiovascular disease, diabetes, cancer, deaths associated with those diseases, they're decreasing as our knowledge is increasing. As I mentioned, that's not happening with depression or other mental illnesses. So, but with cardiovascular disease, we know about risk factors, and people start to change their lifestyle and take medications and such before the heart attack hits. So we need to know through individual differences what puts people at risk so that we can say, take a hike or have more social interactions or start cooking or even take this drug or this vitamin before you have a mental health breakdown or even something neurological like a stroke or something like that. So through individual differences, that's going to allow us to see what is working and what isn't, who's at risk, and what we can do in a preventative way. And that's what we have not done very well, to my knowledge, in this field. And the National Institute of Mental Health has said this, the director as well. So, oops, now I'm not hearing.
Yeah, no, second question is, this is a cute one. Do your rats have names?
Well, I mentioned Mario and Luigi. When Beth Crawford came up with this project, we knew that we would have 2 rats that we would continue to train. So in that case, we trained them, and we knew that they were going to live their lives out in the lab. But most of the time, like with the grant research, they have numbers, but we don't name them. Sometimes the students will, if they have an individual kind of quirkiness or something, they'll call it that. But so I've had rats outside of the lab that I name, but it's a rare occurrence that we name them in the lab.
Okay, and another question here. Has the mental health of the rats changed during COVID isolation?
Oh, wow. That's a good question. Well, we have had, we scaled back, but we have maintained a small population of rats. And with my team, we come in and have been taking care of them. I did notice that with the ones in the rat loft at first, that they weren't going up and down as much. And so I was thinking, oh, maybe they've got the stay-at-home order too, and they're staying just in the upstairs or downstairs. But then we realized that we had put the angle was such that they couldn't get up. But I was making all these parallels. No, you still have to get out. And then I thought maybe they're gaining too much weight to get up there, which the quarantine 15, I think we're all facing. So I thought I was seeing something there, but it was our quarantine brains that we put the tubes up wrong. They don't see as much interaction. So when I think probably I'm the worst one, when I go in, I give them probably more Fruit Loops than the others. So they've been very attentive when I've gone in and given them their little treats. But we haven't done any systematic assessment. So the scientist in me says, well, we can't really tell, but I think they have limited interaction, so they're more in tune with us when we enter the lab. That is a cute question.
And how many rats are in your lab?
Yeah, so it depends on what we're doing. Right now we have about 20, so we're very small scale because we didn't know what the pandemic was going to happen, what was going to happen. So we were supposed to order new animals and we didn't. But we're transitioning. We have a critical care and emergency kind of protocol for Gottwald Science Center now. So I have a post-bac technician who's working on the grant and a postdoctoral assistant. So we're transitioning back to the lab and starting back with the grant because I got behind on that. So we'll have 40 rats arriving Monday. So we're looking forward to introducing them to the lab. We're going to train them on the effort-based rewards and introduce them to Fruit Loops.
What advantages do you see in being at a school like University of Richmond?
It's hard to imagine to me a better place to be. I've already mentioned the students, and the students, they just keep me in a young brain context, and that I think is so important. But they have ideas, and some of the best ideas in the lab have come from the students, because we all know that the older we get stuck in our ways. We think about things the same way. I showed a picture of that maternal rat, and I was here, and I don't know, maybe we've got alumni out here. One of my very best colleagues in the world was Craig Kinsley, who was here, and I'd love to know if you've had him. And together we studied maternal behavior, and it's after the unfortunate circumstance of him passing away that I'm here in his office. A bittersweet, but wonderful to be here. So when we were studying maternal rats and that wonderful behavior, one of my students years ago raised her hand, Dr. Lambert, what about the dad's brain? Why have I not thought of that? Well, rats, they're kind of drive-through. They don't stay around, the kind of deadbeat dads. They don't stay around. But there are mammals, only 5% of mammals invest in paternal care. But I thought, that's a wonderful question. So we found a little mouse called the California deer mouse, and they're paternal and monogamous. They mate for life. Really cute. And so I had a whole National Science Foundation grant to study the mechanisms of paternal behavior to compare to our maternal behavior. And I probably would not have thought of that. And that's just one example of a gazillion where the students make me think of things differently. So the students, the colleagues here are wonderful. The scholarship is so wonderful. So it keeps us just sharp and gives us resources to investigate our interests. And the teaching classes, I learn so much when I teach my own class. That keeps us abreast of all the current material as well. So it's very engaging. This is a very enriched environment. And I love being able to have the teaching and the research. So I could go on and on, but it's been great.
What learnings have you found from the stay-at-home experience?
Oh, good question. I wish I had all of your faces up here so we could all talk about that. It's reinforced what the rats have told me. I feel like I have been in one of those standard laboratory environments now, sitting in my office above my garage, even though I'm out now. And it just I just would feel this yearning for more complexity, not only for physical environment, but oh my goodness, for social environment. And we are a social species, and I could talk about a neurochemical oxytocin, the cuddle chemical, that is increased with social contact. And my daughter, in fact, when I leave here, I'm going home out in the country because I am a country rat. I haven't seen my daughter who works for Westrock since Christmas because of this pandemic. And right now, my nucleus accumbens is going, whoa, because I get to hug her. So that's going to be wonderful. It reminds me how dependent we are on social contact and those social bonds. Wearing a mask, our brains evolved to see a full face. I feel like I'm trapped in a mask. We all need to do it because we need to be safe and use our brains to think through this. But it reminds us of our human predispositions to be out in nature in a complex world, to be around people. It also reminds us that it's hard to change our routines. We get into habits. Ron and I were talking about, it's difficult. She had to create a routine about going to the room in her house to work. And it's interesting, my class that I had before we had the stay-at-home orders, it was an advanced seminar in neuroplasticity. And one of their papers was on habits and what areas of the brain are involved in habits and how hard it is to break a habit because it's just ingrained in our brain. And so all the students they selected a habit that they were going to work on creating or disbanding or something. And we were talking about how hard it is. And I remember one student, she said, you know, I'm going to try to not throw my clothes on the floor, but I just can't. It's so hard for me not to do that. And now I was teasing them when we were having our Zoom class. I said, boy, that sounds easy compared to all the different ways that we've had to change our lives dramatically. So it's been a lot of reminders that we can change through neuroplasticity and that we have these predispositions. It's been difficult for me, you know, just adapting like we all have. We're talking about Zoom and posting things, using discussion boards instead of sitting in front of the students, doing everything distant. I really hope that we'll go back to that this isn't our new normal. I've been reading the Chronicle of Higher Education, you know, how higher education is going to change, if anything, and talking to my students too. And I gave them a little stress survey to hear what they're going through. It makes us appreciate this total, complex, intact environment more than ever. I mean, I think maybe we're taking this for granted. So it's made me appreciate this university experience. And my hope, I know we've all gone through challenges, is that we will use our brains and our neuroplasticity circuits to learn about how to be better and to create a better world. And that's one thing, that's what neuroplasticity is all about, that we can learn and change and adapt in positive ways. So I've been thinking a lot. We're all surviving, but I hope that we get back to something closer to in contact with the students as soon as possible.
One more question. How have you been able to pivot and execute virtual lab work with your students?
Yeah, so I kind of addressed that a little bit. We didn't have time to think about it. We just had to do it, right? It was, as I said, it was challenging, not only because of the technology, and I'm not, you know, I'm more of that real person, kind of in-person kind of professor, but also being aware of what the students are going through. And so it's not just learning to adapt to the new technology, but then all these questions such as if we're having a Zoom class, we have everybody's pictures, you know, with video. What if somebody's in an environment where they don't feel comfortable sharing that environment? So then they have their video muted. I mean, the video, they're not sharing the video, but then that means, you know, how do people interpret that? And what if they're mute, you know, they're in a house and they've got loud thing and they can't control that? So I'm sensitive to when we had what we call synchronous sessions. I only did that with my smaller, you know, with small students, and tried to be on top of who could attend that and could record it for other students without them feeling too different. And also just because we study stress in my lab, how stressful this was for individuals. I know the first week into remote learning, my brother, who's an MD in Atlanta, he had COVID and was rushed to the hospital with respiratory distress. And you know, here I am trying to have a club, but I shared that experience with the students because I was stressed. He's fine now. But another student, at least one of my students had COVID too. Her parents were MDs at Hopkins, and just the stress they were going through. Several of my students had a senior seminar. They're just little things like their senior spring break trip. They didn't go to that. They didn't have graduation. Heart just went out to them. Graduation. Can you imagine not having a graduation ceremony? So trying to be sensitive to what they're going through, but yet trying to be upbeat and positive and letting them know that I was still going to challenge them. It didn't mean that I was going to dilute the course, because these students, they wanted to know that they were not just getting their money's worth, but that they were going to gain the knowledge they needed to have to go on to that next step, you know, studying for the MCAT or whatever next class. And so I kept confirming to them that we're covering all the material. You're not missing out. And this is a new opportunity. And we talked about different, like the immune system and the cytokine storm. So I tried to bring in every relevant example I could, be sensitive to what they're going through. So I probably was a little bit, a lot more we have to all be more understanding. So if someone couldn't do something, because there's absolutely, they could turn things in late. So it's a lot going on, and everybody I almost felt like you're kind of underwater. You can't do things as easily as you usually do. But my experience probably is nothing compared to what so many other people have experienced. But we did it. The students covered the material, not only my class, but others. They got those degrees, and we will continue to do it until we can get back to the best. I hope education we don't just look at the most efficient way to educate ourselves. We need to think of engaging so that we get this long-term kind of return on this investment. So yeah, so those are some of my thoughts about surviving this.
Okay, well, Kelly, thank you so much. I know I've certainly learned a lot from your presentation, and really appreciate the time and effort that you've put into it in these trying times. Again, thank you all for joining us. I hope you'll join us for some upcoming virtual programs throughout the summer. Please note that First Fridays will return in September. And remember to check out the alumni Facebook, Instagram accounts, and the alumni website for further information. And please stay up to date on what's coming next. We hope to see you soon and hope you all are staying safe and healthy. Go Spiders.
Thanks, Rhonda. Thanks, everyone, for your attention.
Thanks, Kelly. It was great.
Bye-bye. Bye.